All right, we are now recording. I need to let everyone know that we're recording. Anything you say can and will be used against you. Not really. But here's the thing. So, ta-da, right? Here's what we're doing. And before we get started, I want to go over a couple things. So I did get a chance to grade the labs for Module 2 for this class. So there's a few things, one of which I know I didn't even realize until actually I came across the lab and somebody was doing it, and I was like, oh yeah, that's right, we should be doing that too. And that was it was really cool because they're like, I think they had, wow, they didn't put a question mark in, but if you remember, we could do multi-line comments like so. Yes. And the reason we want to do that, remember, we need to put our name in there. We want to put the date and we want to put what it is. um And for example, I like graded one lab, and the one lab was like, let's see here. Oh, you can't see my screen? um, it says I have an attachment there. Let me get rid of that. Yeah, I don't know. It should be. Yeah, you should be seeing a sketch, right? I don't know, Michaela. Is it on? Are you on your phone? Are you doing something different than what you normally do? Oh, okay. Um, all right. Yeah, I don't know if you can switch over to your phone though. It might be helpful just to see it at the same time. But yeah, if you can go back over it, download the recording, that'll be the best thing because we will be talking about a lot of stuff today. And we definitely have to see some things. I've got my camera ready to go here so we can look at this stuff, because we need to at least talk about this dude, and then we need to talk about another dude. So when I say dude, Michaela, you're going to be like, what are you even talking about? I'm saying the sensors. Um, we're going to be covering two sensors today. Hopefully, we'll have to see. So yeah, if you can go back over the video, fantastic. But all I'm showing, or all we're looking at right now is, okay, our sketch, and I just want to cover really quickly some expectations, right, for our programs, because they're really programs, right, even though we call them sketches. So at the top, we have the header information. We want to include that. We want to include the instructions, because what I found was there was a couple of labs. And for example, here was a scenario. Somebody copied the code out of here and pasted it into Word. Well, Word did you a favor and said, oh, I'm going to autocorrect, int, and it should be a capital I on that. Well, then when I go to like copy that, it's like it's all messed up, right? So that's why I say the instructions are submit two things. One of which is your sketch. I want to open up your sketch because I want to see it like on, I want to see it in the raw. I want to see it like how it's supposed to be because I need to run it and I need to make sure it works. The other scenario I saw was, again, no instructions up here, and it was just a bunch of, statements. Well, the statements didn't have any comments. So to a person that just looked at it, they'd be like, what does this do? I have no idea, right? So again, you want to comment major parts of your program, even though it seems very straightforward, program it as if, or not program it, but write the code as if, you're giving it to somebody to do something, right? So I hope that makes sense. Just make sure you're commenting, even in a blank sketch, they put comments in here and like what you should do, even though we know what we should do, right? Like, oh yeah, this only runs once in the setup code here. You don't have to keep this comment in here, but we want to put our own comments because again, I have to grade on that criteria. If you look, the labs have the same rubric that we're used to with any other programming assignment. So I just wanted to make sure I reiterated that because I know at some point, and this probably was back in September, August. I mean, that it was like, oh yeah, these programs are the same expectations as any other program. For, and I want to say half of you, but for some of you, you had no problems. You did an excellent job with that. Great work. You named the variables something appropriately. You just didn't use pin number 6, right? Or whatever it was. It was very clear, like pin 6 was to control the LED, or it was for the potentiometer, or, you know, so again, just make sure you're doing that. If you're ever in doubt, just again, send me your code and I can give you comments. Okay. Any questions on that piece? Like generally, you may have individual questions maybe about your code, but you know, again, just email me, all right? But for the most part, that was pretty cool. Everybody got it, got their feedback at any rate. And then I made them, I think I made it videos for everyone, yeah, so I could show you like what I was seeing versus what maybe you should have seen. So, cool. Other than that, I think that is it for general stuff. Okay. So what I want to do then is I want to start where we left off, and I think that, yeah, that's the primary monitor. And here we go. So if you remember, right before this was this. So we were talking about this fixed resistor, and we were talking about the voltage calculator, voltage divider formula, and how I can figure that out. So we could use our potentiometer. So we could use our, oh my gosh, sensor photoresistor, right? And we will, I'm trying to think. Yeah, there's a lab over this, right? So there's a lab over this. Control the intensity of the light, and we went over that last time in class, so that was pretty sweet. I put it together, and it's kind of the highlight of the night around here. I ran around the house with the battery on it, and I was like, "Ooh, look at this LED." It was pretty fun. Now we're going to step up our game a little bit here, guys, and now we're going to get into some cool things. And this little guy, it's in our kit, right? And the one we have in our kit, it's built onto this little board here, and all it is a temperature and humidity sensor. And so with this, you can see it's very, I don't want to say basic, but this is the one that comes with this. This is the one, like if you buy them, you will get. Like if you buy them in bulk, they'll look like this one on the right. It comes in two styles. This is really called a DHT11 is the type of sensor. It's a digital sensor, so which means that the information you get out of it already contains the temperature and humidity, and you don't have to do any calculations, right? Or any conversions, right? So the first thing I want to do is I want to start off with the data sheet. So the data sheet is up here. Up in the up in Moodles. So let me see. It's the DHT11 technical data sheet. So I just want to have a quick look at this. You need to log in first, evidently. Oh my gosh, what do you mean you have to verify it's me? Hi, Aaron. Okay. Yep, that was me. This is what it looks like, and this link again is available up on Moodle under our resources, and there's a whole bunch of stuff that it talks about. I mean, obviously it's a technical data sheet, so it gives you all this information, but what I like to look at, and I'm sure many of you go kind of right to this area too, which are the technical specifications. So I want to see, what does it do, right? I want to look at it, and I want to know what the tolerance are, is, what the range is, right? So we can do measurements from 0 Celsius all the way up to 50 Celsius, 50 degrees Celsius. And for me, I don't know about you, but I'm more of a Fahrenheit person. I can relate to those numbers, where this, I think, what, 0 is freezing in Celsius, and what is it, like 32 degrees Fahrenheit is freezing, so again, you have to do some translating there. 50 degrees Celsius, I don't even know what that is. I know 212 is Fahrenheit boiling water, but 100 degrees Celsius is boiling water. So it's half of boiling water. So it's a really good range. And then your accuracy, this is relative humidity. So RH is relative humidity. When you're measuring the amount of moisture in the air, it ranges from 20% relative humidity up to 90%. So it doesn't go to 100. That would be like sticking it in water. There are sensors that do that and can monitor for water. There's a bunch of stuff out there. And what's nice is you get a temperature accuracy too. So plus or minus 2 degrees Celsius. Now, you know, some of this other stuff, it depends on, and I won't go through all this, but at any rate, I'm just kind of interested in the range, right? So at 0 degrees Celsius, your minimum threshold for relative humidity that you can actually measure is higher at 30. And you can kind of read that, right? So you get an idea. Let's see. Now, what I'm really interested in is the operating specifications. So what does it need here? Down here, right? So the electrical characteristics, power supply. So, well, again, since it's a digital sensor, we can give it some power, some DC current, that's direct current, as opposed to AC, which is alternating current. Now you can see, you know, the minimum is 3 volts up to a maximum of 5.5 volts. So typical is 5 volts. And so what that means for me is that, you know, we get this range. So you can plug it into things like the Arduino Duo or the Arduino Pro Mini that operate at 3.3 volts. And, you know, you can plug it into those boards, you know, or those microcontrollers, and it'll work. So that's just great. There is another thing. There's a refresh. Let's see what that is. I think that's back up here. Oh, yeah, right here. Response time. So this is an important thing to take note of. And I can make that a little bit bigger. So response time in seconds. So this is basically the update, like how often does it update? Because what you don't want to do, and it makes no sense to over query your sensor, right? If, you know, and I would say I would go with the maximum, and really these, I think, depend on temperatures and some other factors, but really I wouldn't sample this sensor more than every 15 seconds. Because if I do it every second, I'm getting the same value back, right? So again, I don't want to over query it because it doesn't really make much sense. So when you put together this lab over this component, again, put a delay in there. And that could be hard coded to 10, 15 seconds or something. So you don't over sample it. Let's see here. Now we have to look at the schematic. So let's look at this guy. Make sure I get the right one. Yeah, here we go. So this is how we wire it up, right? And you can see it's very straightforward. You know, this is looking at it from the front. So this is looking at it from the grill port. So, you know, if I'm doing this, you can see my great drawing here. But if I'm looking for pin 1 is going to be off to the left. Pin 2 is going to be right next to it. Pin 3 we're actually not going to use, or pin 4. Now you'll notice on ours we only have the 3 pins, so we have 1, 2, and 4 off of this schematic. So when we're working with ours that come with our kits, sensor is going to be all the way to the left. 5 volts is going to be right here, and then ground is going to be all the way over to the right, just like the picture on the slides, right? So again, that's how this is wired up. And you'll notice what's interesting about this schematic. So I'll let you guys look at that for a second. What do you notice interesting here besides you plug it in here and I'm monitoring pin number 2? What do we see in there? What other component do we see in there?
I mean, there's a 10K ohm resistor.
Mm-hmm. Right. So that 10K ohm resistor is in there as our pull up resistor. because if you remember, it's the same thing as a button, because that's what I noticed in the lab last week. Some of you included a pull down, or well, it would have been a pull down resistor, or you included that in your circuit and you needed to have that because we had no way the button state was fluctuating. So all we're saying is, if there's nothing coming out of the sensor, I need to pull it to something. I have to have some kind of a reading. Okay, so again, this is a pull-up resistor and it's required so that way I don't have any fluctuations, right? I want to get an accurate reading, and again, you just need to include that pull down, or this in this case, pull up resistor. What else with that? On the grill, pull up resistor. Again, that's pull up resistor if there's nothing to be read from the sensor. All right, well now we have to, we need to do two things. We need to wire it up, and then we also need to download a library. And so this will be our first look at, like, hey, we have this component, and hey, there's already a library out there. Let's just download it. So let's switch over to our camera here, wherever that be. And let's wire this up real quick. Now, I think I already have a sketch for this done. Let me make sure. Well, no, I don't. It doesn't really matter. So let's just wire this up really quick. And we said that all the way over to our left is going to be our sensor. So that's the value I want to read. And I'll just put it into pin, I don't know, 7. Let's make it an even number. We'll put it at 8. And then from here, right, we said 5 volts is the next one. Might as well use a nice red one. So we'll put in 5, and then we'll put it next to that. And then the next guy is ground. And again, this only takes like 30 seconds to hook up. This is pretty nice. So I'm going to plug him into ground. Now I have already wrote a, I already wrote a blank sketch to this, so I don't have to worry about it. That's why I had that blank sketch open, so I could just wire this up real quick. There we go. So you can see, I mean, honestly, that's it. You have 3 wires and they go into the, this is the only interesting one. This is data I'm reading, and then these other ones are 5 volts and ground. So very straightforward. But when we get into the sketch, this is a little tough. What I mean by tough is this is a little involved here. So this is how we do it. We go to our tools, and then we manage libraries. And then you want to look up, where to go? There it is. So now there's a bunch of libraries here. Well, we want to search for some, and oh my gosh, you got to download the libraries index. Okay, we're waiting for it to update or refresh. And I'm just going to search for DHT sensor library. Okay. Now the one we're looking for, the one we want, is by Adafruit. Adafruit is just a company that does a lot of work with different sensors. They're like, what do you want to call it? They're like kind of the, I don't want to say they're the name brand, but they're the main company that writes code for devices. And most times, and maybe it's not even devices they make. So we want the one for this because you can see it says Adreno library for the DHT11. That's exactly what we want. So now I can go in and just hit install. And it needs some other library dependencies. So it needs the Adafruit unified sensors. Would you like to also do that one? And yes, say install all to that. And you'll download it, and voila. And I mentioned this a long time ago. When you download a library, right, you actually also get some examples that come along with that. So if I go down here, you'll see I have the Adafruit Unified Sensor Library, right? There's not much interesting there, but the one we care about is this DHT sensor library at the bottom. So again, I don't know if you can see that, but this is what it looks like, right? So I have 2 things there. We'll want one of those. Which one do we want? The DHT unified sensor one. Yikes, come on, examples. DHT unified sensor. Now, if I open up this, or when I open up this, you're going to see that, hey, voila. And this, we should be very comfortable with these at this point, right? These are libraries, right? These are just class files, right? And moreover, like I said before, you can see it's .h. I don't see any .cpp. So that means that our implementation and our specification files are combined into one, right? So we could go into each of these files and look at some really cool stuff. It's very complicated because we're just going to look at how do we use it, not so much worry about what's going on under the hood, because those files are a little intimidating. So, you know, again, and that's not part of this class, right? That's not what we care about in this class. What we do care about is defining some stuff. So we can say define DHT pin. So now we have a little bit, instead of saying int button state equal to 2, right? Well, we could define specific variables, right? This would be like, I'm defining pin 2 as this name. So anytime I see DHT pin in my code here, like here, that's really the equivalent of a 2. So I said I'm going to plug mine into pin 8. So all I have to do is make one change. I don't have to change anything else. The other thing I need to be concerned about is what type of sensor am I using, right? So I need to uncomment the one I'm using, which is the DHT11. So you'll need to make that change on the example for this to work out for us. Then, and I'm going to go through this. I'm going to go through the major lines, kind of, I don't want to say line by line here. And you know what? Just to make life easier on ourselves, this is what I'm going to do. I'm going to open this up in Visual Studio, or no, CodeWriter is just as good here for what we're doing. Plus, it looks a lot cooler, right? Okay, so I want to start with line 26 because we know now that what's going on here with this statement. Isn't this cool? I mean, for real, right? Because I know I'm creating some new type of object, right? It's a DHT underscore unified. That's the class name, but my object is going to be a DHT. I'm passing it 2 parameters here, right? The pin number and then whatever type it is. You know, again, to worry about the time, like I don't really care about that. But again, this is the important piece for us because again, this is something that we're using and doing, everyone's doing in the other class. So if I go down the list here, certainly we're going to output all our values to the serial monitor, right? Because that's like the easiest thing. That's like the console for us and our other programs. So serial.begin, I need to initialize that. Line 33, this is me actually starting the sensor. So I'm going out, I'm saying, hey, you know what? DHT.begin, right? That's a member function for my object DHT to go ahead and do something, to start running, right? And so then I'm going to go to 36. You can see here, I'm also now pulling, this is going to be in another library, but I'm creating a new object here so we can refer to the sensor in the code using the DHT unified class. So again, this is just a way for me to pass around the actual sensor. Again, I'm not too concerned with going under the hood. That again is not the intent of the class. That's why we're going to use this code in our own programs. We are not going to rewrite this. We are not going to analyze it because again, this is a 215 class. This is not a 315 class, right? But you're certainly more than welcome to go deeper on this if you want. Let's see, 37 and really 48. These are our friends, okay? Because lines 37 and 48, we're using member functions to get both the beginning there, get the sensor temperature and humidity specifications, right? That's that's the stuff used to report the sensor information. So this is how I'll like, and it's a getter, right? It's a getter function. We know it's an accessor function. It's getting something. What are we getting? Well, we're getting the information from the sensor. So again, that's on lines 37 and 48, and those are important. And that would be like, I would make a comment there or just highlight it or something. So whenever you query that, whenever you say get sensor, that member function, you are getting returned, in this case, the temperature, because it's listed right there, or you're getting the humidity because it's listed right there, right? So I hope you can kind of see that and read it, okay? Everything else, this is just outputting stuff to the serial monitor, um, and you can see exactly what I'm getting, the name, the version. I'm getting those private member variables of that sensor object, right? Let's see. Yeah. Yeah, delay between, you see that delay there? So you can see the sensor dot minimum delay. So what's interesting here is because it says there's a minimum delay, you are actually delaying the amount that you should based on what the sensor is. So, the DHT11, the DHT22, all these different ones have different delays, just like we saw on this technical specification sheet. So all we're doing is having a variable for that. So that way I can just refer to it as this and not put some static number in there. Let's see, I'm going to jump up to, yeah, that's 58. 65, right? Now this declares a new object, and the new object here called event allows us to get either the temperature or humidity, right? So up here, right, I'm just printing it directly here. I'm just being able to refer to it as event, right? So I don't have to look at everything else. 65, that's 65, 66, right? Using a member function to get the actual temperature in this case. And again, we just need to look at these member functions to see what they're doing. And then 67 is nan, right? Is nan. I don't think we ever looked at that, but it's just a C function, and it stands for is not a number, right? Is not a number, right? If it's not a number, then there's some kind of error because I want a number back, right? Otherwise, it's going to print it in Celsius, right? The one little weird thing here is F, right? Like, what's F? Well, here, I'll just, because it's more than I'm willing to go into, but if I look up here, if you want to know more about it, here's the link. Right, so you can read over that, and it's a kind of a lengthy description, but again, if you wanted to see what F was actually doing, you could take a look at it there. Okay, so, and that is, and here we're in the loop, right? So we're actually doing something. Like all this stuff was like set up and initialization. This is us actually doing something. So you can see that's it. So again, I think by just going through it, highlighting those like complicated lines and identifying what they are will help us in knowing what's going on. And we should all have a pretty good understanding of this. But again, if we came straight from like 205, this might be a little daunting. But at any rate, that's it. Now we have to just use it, right? So if I have this and I have everything set up right, and I change my pin number to 8, okay, I think everything is okay. So let's Well, let's verify it first, just to make sure that I didn't forget something. Compile it, looks good. Now let's go ahead and upload it. And then after we upload it, we'll be able to pop open our serial monitor. And hopefully we can see something going on here. Well, now I missed it, right? Yeah, there we go. So you can see currently the temperature is 22.8 degrees Celsius with 63 degrees or 63% humidity. Now, this is a little gross, but what you want to see is I'm going to breathe on this. I'm going to go like just. I'm going to give this sensor COVID, right? And sure enough, boom, it jumped all the way up to 95%. And I guess my, and if you, let's stop auto scrolling for a second so we can kind of see where the comparison or where it changed. It was at 22.8. Now it's up to 24.3, right? 24.6. Now what we should see is it's kind of tapped out there, if you will. And maybe I'll just kind of wave over it a little bit. Well, now we maybe want auto scroll. And we'll have to wait our 10 seconds, right? We'll have to wait for it to drop back down because it should slowly start to drop back down, and you can see it happening. Now the humidity, I must have got some, what do you call those, droplets on it. Well, now it's starting to drop down a little bit because I probably kicked it over 100, right? Because I have very, I was breathing on it too heavy, I guess. But you can see it's dropping back down. And that is it. I mean, honestly, how cool is that? This little guy here can do all this stuff. It can take the temperature, read that, kick it out to a pin, but also it can measure the relative humidity too. I mean, very awesome. And it's so easy to wire up. I mean, how can we beat that? One wire, and it does all of that. And like I said, when we use this component in our program, we are literally going to copy and paste. Now, here's a scenario where, do you see the comments at the top, right? Now, since I'm going to be using this in my own sketch, what you would say is, you would just include these comments. Just include these comments in addition to your own, because it's like you're borrowing from here. I'm perfectly fine with that. Just make sure you give Tony, what is that, DeCola, make sure you give him some credit, right? Because he did all this stuff. And he did all this stuff mainly. These are the, did he do all these things? Well, he didn't write these libraries. If you go into library files, you will see, and again, if you're curious, you can go in and look at those. You can see that they're probably developed by other people. But at any rate, all of this stuff is things that he developed. So if you use that, I recommend you do, and don't change it. Just make sure you give him credit. That's pretty much it, guys. Any questions with that?
So this next lab for this one's pretty much just adding some if statements to turn on an LED. That's about it.
Well, no, it's a little bit more than that. I I had to go back. If we're looking at the lab, it's lab 2. It's actually it's the most difficult lab. You're gonna have a microcontroller respond to environmental conditions. Well, we just saw 2 environmental conditions, right? But we really are just looking at the temperature, because what you're going to see is, we're going to go through this, but we can't go through this lab until I talk about the next component, because we have to talk about distance. Okay. And then, yeah, if the temperature is below a certain threshold, we're going to turn off LED. If it's above a certain threshold, so I will go over this lab once we go over the next sensor. But yeah, that's kind of what it is. There's actually a little scenario that I have based on this. It's probably not as creative as Professor Wedge does with his scenarios, but I have something to give us some point of reference. But I'll talk about that in a minute. Anything else? Cool. I don't know why that popped up again. So we're talking about that. Ready. We looked at both of those. We looked at, yeah, and that's it. I mean, it's a pretty straightforward sensor. Now we know how it works. So that's really cool. So now what? Let's talk about this guy. This is our ultrasonic sensor. Looks like a boombox, right? Looks like, you know, maybe I can get some speakers out of that. But what this is I'm really going to look at how we can measure the distance between whatever prototype or gadget I put together here and a target that is in front of it. To do that, we're going to use this ultrasonic sensor. Now, this type of sensor, it's really the same thing as sonar that you use in like ships or submarines. And what it is a high frequency sound, right? That's what this was, what sonar is a high frequency sound that can't be heard by humans, and it's emitted and then it's bounced off a target object and then it comes back. That the Adreno or the sensor measures the amount of time it takes for the sound to do the round trip from the sensor to the target and then back, right? So what we're measuring is, hold on, let me get my mouse over here. So what we're measuring is if the sensor is here, right, and I have some object over here, looks like a wall, you know, sound waves come out, maybe they do something like this, and then they hit that, and then they bounce back, right? And we're just measuring the amount of time that happens. Now, you're going to see in the code, there's a lot of numbers and stuff in there. In the numbers and stuff in there, well, maybe I'll hold off on talking about that because depending on the type of well, I can just tell you really quick. Depending on the type of environment, like for example, if we're underwater, there's going to be a different calculation to use to figure out this distance. If the air is really dry and there's not a lot of, you know, if there's a lot of dust in there, I mean, if there's all these environmental conditions, even light can have an influence on the sound waves. So again, there's a lot of figuring out there, but we're not too concerned about it, right? This isn't a class on like physics, and I don't know that stuff, so we're not going to talk about it. But some limitations we should be aware of, right? Obviously, if the object that we're trying to bounce a sound off of either absorbs the sound, like a soundproof room, think of like that, or you know, if there's other things in the way, you know, that will influence our distance. So we just have to be aware of that. You know, if I can't get a good bounce off the sound, you know, you want to use something nice and hard, solid, so you get a good bounce back of sound there. So that's just something to be aware of. Again, if you're not familiar with ultrasonic, how that works, you might want to read up on it a little bit so you have a better idea of the application of it in our lab, but I think it'll be pretty straightforward. Let's see. Okay, so now I do have a bunch of things here. So I have an image and then I have this specification sheet. That should open up. I mean, the link is a relative link. So let's see if we can open that up. Right, so here's a similar, just like we had with our DHT11 sensor. You know, this is the HCSR04. And I think that's even the name of it. Hold on. So if you look on this component, sorry for the trumpet in the background. I can actually hear that through my headphones. But if you look stamped right on the middle, it says HCSR04. So this is the exact component that we're using. Talks a little bit about the sensor, the object, right? And you can see what we were talking about. Now this talks a little bit more about the speed of sound and how it's calculated, and just again in more details. But I want to see the specifications. What's the power supply? 5 volts. The range here, right? The range is interesting. So it's accurate from 2 centimeters all the way up to 400 centimeters. I think 400 centimeters is something like 10 feet or something like that. I don't even know how to do that conversion, and I don't know. I don't know. And that you can buy it for like $2. Okay. So what does it look like specification? What's the, well, actually I had it already open. So when we're talking about wiring it up, again, we have to look at it as this is the front. And if we're not sure, we can do this. Right. And everything is measured from the front. So you can see stamped on there very, and again, let me zoom in a little bit. You can see stamped on there, it says, whoa. You can see stamped on here, VCC. Well, we know that's where our 5 volts is going to go. And then we have 2 pins, trigger and echo. Well, we know what ground and we know what 5 volts is. We know we can plug that in, no problem. Trigger and echo, though, where before we had like we're reading one thing. Well, here we are reading one thing. Well, we're actually reading an echo, but we're also using trigger to start it. So it's like we have to start the sound and then we have to measure it. Does that make sense? So one of these is we're starting it, and the other one we're measuring to see the amount of time. All right, let's see. Whoops. Oh. So when we're wiring this up, we just want to look at it, and I'm going to, I think we just wired up now. Let me look. All right. Okay. Now, this doesn't have a library to go along with it because, well, we'll see what happens here. So let's go back to our sketch, and I will open up a blank one. No. Just make a new one. Why not? Now I want to just, even though I'm not going to use the same pins, I mean, again, it's a good habit just to get into this, just to, zero it out, if you will. I think I even had the, make sure you have your serial monitor closed if you're going to write anything. Just to avoid any errors. So I'm going to unplug my sensor here. And I'm going to wire it up just like this. I know 5 volts goes to the left. 5 volts here. And this one may actually be, it's actually a little bit easier to wire it from the back. So if you do that, so that way I can get into it a little bit easier because those little speakers get in the way. If I do that, everything's reversed, right? So my 5 volts is going to be over there. My ground's going to be on this side. And then I'll probably want some long ones for this. So we'll do a dark one. We'll do still our reading. So we'll do our echo orange. And then our trigger blue. Now we have to figure out where we're going to plug these cables in. So whatever pins. Now I put up code in Moodle. So because again, it's just too much to try and, type up. So for this example, just go up to Moodle and you'll see there's an INO file up there. It's called ultrasonic sensor. And if you click on it, it should open up just like this. So you can take that and paste that. Now with this, it's interesting because there's actually nobody took any credit for this. So, okay. Now what they're saying here, right? So if I'm looking on the Uno, it's pins 12 and 13. Okay. But again, I can change those if I want, no problem. But why not just, again, it doesn't matter. So I just need to wire it up with pin 13 being the trigger pin. And that's going to be in my case, my blue wire. So I'm going to put that in 13, and then I'm going to put him in 12. Okay. And anything else here? This was the formula that I was talking about. That's a little wonky. And again, because distance isn't, this is just environmental stuff. So again, the formula, I mean, you could go over it if you're into physics, but I'm just not. But everything else should be pretty straightforward, and it's pretty vanilla, if you will. And I'm saying this must be 0 to 200. Maybe, I don't know. That's the number we get back. Well, let's see. Because it's, again, measured in centimeters. So it does say that it's supposed to be 400. So we should theoretically be able to change this to 400. I don't know why it's set to 200. But at any rate, I'm going to upload this sketch. I'm going to open my serial monitor. No. Save it to the desktop. Alrighty. Now out of the gate, after this is done, it should be reading out of range, right? Because if I'm looking at my picture, let me move this over here. Picture, that's too small. Right? There's nothing in front of it. So what I would like to do is probably place something in front of it. So I have my stapler here, and you can see that, well, you really can't. I can move this a little bit. You can see I put my stapler there, right? So now I have my stapler up here, and it's measuring the distance from the stapler to the sensor. So again, if I move it a little bit closer, right? 14 centimeters. How is that? Yeah, that sounds a little bit better. 9 centimeters. If I move it away, maybe I just move the sensor. Maybe that'll be easier. Okay, and you can see that it's right. The distance is about 17 meters there. So that's it, right? That's all I'm measuring. Now, again, here's I should be out of range, but here's something like that. You can see that gets a little weird, right? Because again, this is ankle tape. So it's giving me some weird readings, right? That's actually close enough to where it's bouncing and hitting that. If I use my other one, that's a big dog, right? Do you see how it's like out of range, even though this object's like pretty much in front of it? And then you have to worry about the spread, right? How far does it go out? It kind of looks like that's kind of working. So again, when you're using an object, kind of making sure it's like kind of larger. And you can do you can do stuff like your hand too, right? But you can see that, that's a little maybe bumpy. I would have to hold it very steady. I move it out a little bit, right? So you can see, cool. All right, and that's it. So again, these aren't overly complicated sensors, right? They're not, as long as we're using like some predefined code that we don't have to write. Fantastic. So I don't want us to get too hung up on that. All I want us to do is like think about the logic. So let's keep an eye on the time here, because I'm never know what these classes are really messing me up. 10:50. So we have 30 minutes, no, 26 minutes or 20 so minutes. So I'd like to talk about the lab. Just like we did last time, right? We looked at this sensor and then we talked about the lab. Well, this lab is actually two sensors built into one. So I want to talk about that. And again, like I said, this is the most complicated lab because there's a lot of stuff going on. And I think it helps to frame it in some sort of application. So that way we have an idea of what we're doing. Because if we read all this stuff, right, like what are we trying to do here? Well, here's my idea. Well, it even says up here in the instructions, you're programming a microcontroller to respond to environmental conditions. You do not know what system it will be used in, but you do know that it must operate within the given parameters of the DHT11 temperature and humidity module data sheet. And again, the PDF is there. Pseudocode for your sketch should be as follows. So, I use this word pseudocode. So you think back to really, what we're seeing in 315 now, but what we've really seen throughout almost all of our programming classes, which is, start with putting this stuff really in your code. Does that make sense? So like in your sketch, put this stuff in there, because it's like, you want to do this stuff, but you just don't know how to program for it. And then once you do that, you have an idea what you need to do as far as your code. But the application of it would be something like this. I have, and again, maybe you want to think of it in these terms. Like I have this little robot. Maybe it's like a tank. And on this little tank, right, it's got, a couple of sensors, right? And what you want to do is you want to measure, I'll put it red, the amount of, if I had other colors, this is supposed to be fire. So you're going to roll this little guy in here. You're going to move it based on what environmental conditions it's picking up. So you want to move it closer until it gets to a certain point where it's too hot, because you want to know that that's the threshold for, as close you can get to this fire before you spontaneously combust or something, right? So again, you can put this in any kind of frame it however you want. But that's kind of an application that I thought would be something interesting. And I know you guys love my illustrations here, so that's why I did that. And that's what we're doing. So, you're going to get a reading from the DHT, and we know how to do that. We use that event, right? We use that variable in our example of the DHT. We get the distance from the object. We already know how to do that. We just looked at it. That went over. Yeah, right? We know how to get the distance. And then based on those values, I'm going to make some decisions. So if the distance of the object has decreased, right, you're moving closer, you want to output the reading, right? If you're moving closer, you want to just output the reading. Okay, I'm at 10 centimeters. It was 12. If the distance has increased or has not changed, we want to output a message that says like, has not moved. Again, and this is where it's like, you could really kind of put in your own interpretation of what this is, but again, you just output a message. Distance has not increased, or I'm sorry, the distance has increased, larger number, or it's the same. Sounds like a greater than or less than, or less than or greater, right? Now you're going to say, all right, well, if the temperature is below 50 degrees, you're going to turn off an LED. So you're going to have to, in addition to those two sensors, And again, I could wire it up for you and show you. I think I have enough time. Or I can do it later. It depends on the time. You're going to turn off the LED. You're going to wait the maximum response time for the module. So we know we can look at that and see that it's 15 seconds. So we're going to wait the maximum amount of time. And then we're going to output a message of the current temp and humidity. And then we're going to output a message stating that the temperature is below, right? So if the temperature is below 50 degrees Celsius, we're going to output a message. Now, if it's above 50 degrees Celsius, we're going to pop on an LED. We're going to turn on LED, and we're going to say just pretty much the opposite, right? So that's what it is. And again, now that we've went over everything, I don't think this will be too difficult to implement. All right, so what questions do you guys have? Oh, yeah. Hey, Devin. Yeah, so the links on the PowerPoint, right? Those links are really just these resources. These are the resources that I have. If you look at the, like one of them is a schematic. The other one is the thing I opened up here. Yeah, like what does that F function do? That was a while ago. And the reason for that is, I'll show you in a sec here. You can see I should be able to mouse over this. Yeah, here we go. Oh, come on, I missed it.
Is it because the link is a hyperlink to your like location or hard drive or something?
Yeah. I can't get it. I don't, you can't really, it pops up so fast there. If I just leave it over there and I don't try to do anything, you can see that it's in a folder. If you want those images, I mean, let me know. I can just put them somewhere and give them to you. Like, for example, this one, you know, this was just information about the ultrasonic sensor. And again, unless you're really into, like I said, if you're really into physics and want to know how that works, you know, a lot of this stuff, like how do you determine what distance is? Well, it's speed times the meters times 1e6 microseconds times 58 microseconds over centimeters. I don't expect us. That's like too much math. But it talks a little bit about those environmental things, which is kind of interesting. So yeah, if you want those, let me know. I mean, here I'll just throw them in the meeting, and then that way you have them. So let me find them. Let's see, that was 13 and 12. And then, yeah, that's a small file. And then it was this one too. All right. So I'll pop them up in the meeting so you can go and you can refer to them. It's still uploading. All right. Send. Okay, so those links those resources are up there in the meeting too. Or, well, no, it says it's still sending because you got to keep in mind my upload's a piece of garbage, even though I'm using my hotspot. All right. Now, I didn't really want to talk about the next thing because the next thing is really easy. So I didn't want to talk about that. Oh my gosh, it said it failed to send those files. Oh my gosh, what a piece of garbage. And again, I think it's because my computer recognizes I'm on a metered connection. So as soon as that happens, it's like all this stuff happens. Right now I'm paying overage for my data plan. So at any rate, I don't know.
It's not a big deal. I can just look at them in the meeting, like the recording.
Yeah, I scrolled through them so you can at least see them. So you can go back to the video. You can be like, oh, just pause the video. You can read that. I scrolled through all of it. It popped up. So I mean, there's your, and then just take a screenshot, right? And you'll have it. Cool. All right. So then we have two options. So let's do a poll. See what you guys want to do for the last less than 20 minutes of class here. If I wire it up, it might take me 5 minutes to get it wired up for us. And I already have the code done so we can see how it's supposed to function. Well, I have to put an LED in there too. I may run out of real estate on my little board. I have 2 of them. I'll just use 2 of them. But it may take me 8 minutes to set it up then. I don't think it'll take me that long. We could do that, or we could cover the very last thing for this module and then really be done with the module. And we really are good until October, wow, 26th. I don't know. I don't think we should go into the last lab. I think we should stay here for a bit, but then Thursday we'll maybe talk about the button, and that would be one that we could do pretty easily. I could see that this lab is a lot of wires being connected and pretty intense. So I think I'm going to override a vote and say I'm not going to wire this up now. I'm going to go to Defiance today, and I'm going to pick up my larger board. So, because I'm going to need a lot of room, I'm not going to be able to do it on this little dinky board I have. This little dinky board is just going to be too confusing and too difficult. I want to spread this stuff out so we can see what's going on over here, what's going on over here, what's going on with the LED. Trying to put all these wires together, it's just going to be too chaotic. I'm still going to keep the due date for all the module stuff. If you guys haven't looked, now's the time to look. You can see that this stuff's not due until Monday, October 26th. So it's really not due for 2 weeks, because again, there's a lot of moving pieces. We talked about importing libraries. I mean, there's a lot of stuff going on here, right? So I really want to kind of work with you guys. We're scheduled to come back to class the 19th. So I mean, you can start playing around with this. Maybe you want to play around with the individual components like we did today, just to get a feel for them. You know, that's the humidity, that's a DHT11, and then the SC, whatever, I don't know, HC SR04 sensor. You want to plug those in and play around with them individually. But honestly, to put it all together, we have to have some more real estate here. So I'll get that board today and we'll see what we want to do on Thursday. Maybe on Thursday, we want to just finish it off, if you will. And what I mean by that is the last slide here is a button duration. And it's very, it says right here, just a quick demo, because there's not a lot of stuff going on with it. But we do have a lab over it. So you may want to even do this lab first after Thursday, before you attempt the other lab, which is lab 2. Okay. Yeah, so, you know, I think we have enough on our plate here with worrying about these things. Getting a handle on this, importing libraries. I mean, there's a lot of stuff. So here's what I think we should do for the last 10 minutes of class here is is what? Well, it is Monday, isn't it? So I like to make Monday fun day. And so I think we'll probably we'll end class a few minutes early. So we'll do that. But I do want to make sure that there's no questions over what we've covered, what we talked about. You know, again, some of you may not have even fired up the IDE, right? And you may not even have looked at anything here. That's okay. But you want to take some time between now and really Monday before we come back to, well, and I know in at least one scenario, you may not have access to your IDE. And again, you're going to have to find some system to be able to work on this stuff outside of our lab. Whatever you need, if you need to check out, I can get you a physical system, like I can't get you a laptop, but I can get you a desktop computer so you can but I think that, I don't know if those can leave the Defiance College premises. I don't know. I could find out. So again, let me know what you need, right? What do you need? What tools do you need? And between now and really Monday, work on these two guys. Get your library in there. You don't need a library for this, but you do for the other one, which is this guy, right? And maybe you want to take some time and look at individual these classes and see what they do. All right. Any other questions? No. All right, guys. Well then, Thursday we'll talk about the button. I will have enough stuff here to wire up the lab for lab 2. And honestly, I could probably just knock out lab 3 real quick and at least wire it up, show you what it should look like or what it can look like. And then when we come back next week, we'll have 2 lab days. So Monday and Thursday next. Sorry, is that even right? Am I even thinking about this right, or am I wrong? We're back next week, right?
October 19th is the date they gave us.
All right, hold on.
Which is next Monday.
Yeah. Okay, so next Monday, the 19th and the 22nd, those will be lab days. And that will, between those 2 days, 100%, we better have our labs ready for the 26th. Maybe you don't have all the comments, and I don't know, but we're going to take those 2 days to work on this stuff. But in the interim, for this course, certainly play around with the sensors so you get an idea, because I can tell you the biggest thing that people got tripped up on was working with the DHT11, because obviously it's a lot more complex. But when you start to, for example, event up here, how is that being different? What I mean by that is you have sensors, event, and it's just called event. So when I get the temperature, I query the temperature, right? And then do you see down here, I'm actually querying the humidity. So what I saw people doing a lot was the information was not getting updated. Like, think of this as the line that updates it, okay? Because you're using the same name event here. Now you could use 2 variables and then they wouldn't have to worry about that. You wouldn't have to worry about querying it every time before you retrieved it. And I know that may not make sense, but I can show you kind of line by line what is happening there. But that's the only problem I saw people having, was that they were not getting updated information. And the reason is they were not querying the sensor between getting a new value, if that makes sense. So at any rate, that was the biggest hurdle I saw. So go through these examples and see what you come up with. All right. If there's nothing else, guys, then I'm all set. I'll stop recording. And